day. My name is Kimberly Arjimala, and in this video, I'm going to show you my problem and how are we going to prove it using direct proof, indirect proof, and PMI. So now let's begin. So here is now my midterm examination in BS Ed Math 17. So the problem that I have chosen is let x be an element of z or integer. If fx minus 7 is even, then x is odd. So now let's try to prove it using direct proof. So here is my proof. So in direct proof, we are going to prove that the truth value of p implies q. So we let 5x minus 7 be even. Then 5x minus 7 equals 2k, right? Since it is even, any number that we multiplied with 2 is always even. For all k is an element of z, to show x is odd, we are going to show that x is odd. Now we have 5x minus 7 equals 2k. X equals 5x minus 7 plus negative 4x plus 7. So we are going to equate it with x. And in order to be equal with x, we're going to combine it with negative 4x plus 7. Okay? So when we combine 5x and negative 4x, the result will be x. And negative 7 plus positive 7, the answer is 0. So the two equations are now equal. So x equals 2k minus 4x plus 7. We can actually substitute 5x minus 7 as 2k because it is stated above, and minus 4x plus 7. After that one, 2k minus 4x plus 7, we can actually write this as 2 multiplied with k minus 2x plus 3 plus 1. And x equals 2l plus 1, where l equals k minus 2x plus 3, which is an element of z. Hence, x is odd. Therefore, the statement is true using the technique of direct proof. So, same problem. We're going to use same problem for indirect proof. So, let x be an element of z. If 5x minus 7 is even, then x is odd. So, let's try to prove it using contrapositive. So, in contrapositive, we use not q implies not p. So, for our proof, our q is let x is odd, and the negation of that one is x is even. So, we let x be even. Then, x equals 2k for all k an element of z. So, we equate it with 2k because any number that we multiplied with 2, the answer is always even. We need to show that 5x minus 7 is odd. Okay? So now we have here 5x minus 7 equals 5 times 2k minus 7. We actually substitute x with 2k. Next, we are going to multiply 5 times 2k. So that will become 10k minus 7. Next, 10k minus 7 can also be written as 2 times 5k minus 4 plus 1. Okay? After that one, we have 5x minus 7 equals 2l plus 1, where L equals 5k minus 4, which is an element of Z. Hence, 5x minus 7 is odd. So why is it odd? Because any number that we multiplied with 2, the answer is even. However, when we add 1 to it, the answer is always odd, right? Therefore, the statement is true using the technique of proof by contrapositive. End of proof. Next, we're going to use the same problem for contradiction. So let x be an element of Z. If 5x minus 7 is even, then x is odd. So in contradiction, we first assume that the hypothesis is true, but the conclusion is false. Okay? So we let 5x minus 7 be even, and x is even. Our conclusion here is false. Okay? Then we have 5x minus 7 equals 2k, which can also be written as x equals 2k minus 4x plus 7. We actually got this one using the subtraction property of equality and addition property of equality. And x equals 2L. Since our x is even, we can multiply it with 2 and use different variable that will represent each equation. So for all k and l are an element of z or integer. Okay, so for our x is equal to 2l and our 5x minus 7 is equal to 2k. Hence, we have 2l equals x. Okay, it is stated above that x is equal to 2l. Next, 2l equals 2k minus 4x plus 7. So our x can also be written as 2k minus 4x plus 7. So we got this from here, from above also. 2l equals 2k minus 4x plus 6 plus 1. So 2k minus 4x plus 7 can also be written as 2k minus 4x plus 6 plus 1. And after that one, we need to show that 2l equals 2. It can also be written as k minus 2x plus 3 plus 1. Okay. Thus, 1 is equal to 2l minus 2 multiplied with k minus 2x plus 3. And also equal to 2 multiplied with l minus the quantity k minus 2x plus 3, which is also equal to 2 multiplied with L minus k plus 2x minus 3, where L minus k plus 2x minus 3 is an integer. So, it is a contradiction because 1 shows that it is divisible by 2 with the integer L minus k plus 2x minus 3 as quotient. Hence, we cannot assume that the assertion is false. Therefore, it must be true. So yay, we're done with proving using the direct proof, contrapositive, and contradiction. Now let's proceed to PMI, or the mathematical induction. Mathematical induction are usually used to prove assertions regarding positive integers. So the problem that I have chosen is prove that 3 plus 7 plus 11 plus dot 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 plus 4n minus 1 is equal to n times 2n plus 1 for all positive integers n. So here is now our proof. So we first prove that we let Pn equals is to 3 plus 7 plus 11 plus dot 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 plus 4n minus 1 equals n times 2n plus 1 for all positive integers, and this is actually our problem. So we let that one Pn. That's for our Pn. And we need to show first Pn is true for n is equal to m, and for all k greater or equal to m, if pk is true, then pk plus 1 is also true. So let's first prove the first property. So Pn is true for n equals m. For n is equal to 1, we have 4n minus 1 equals n times 2n plus 1. We got this from here. And we substitute n with 1. So we have 4 times 1 minus 1 equals 1 times 2 times 1 plus 1. And the answer here is 3, and the other side, the answer is also 3. Hence, the assertion holds for n equals 1. So this is true. We already proved that Pn is true for n equals m. Next, we are going to prove the other property. So we have for all k greater or equal to m, if pk is true, then pk plus 1 is also true. So first, we assume that pk is true for some positive integer k. Example, pk is to 3 plus 7 plus 11 plus dot 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 plus 4k minus 1 equals k times 2k plus 1. We actually replace all variable n with k, with variable k. So we will now prove that pk plus 1 is also true. So we have, this is our given, 3 plus 7 plus 11 plus dot 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 plus 4k minus 1 equals k times 2k plus 1. So we are going to add k plus 1 in every k. So we have 3 plus 7 plus 11 plus dot 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 plus 4k minus 1 plus, we have here 4 multiplied it with k plus 1 minus 1. And whatever equation we add in the left side shall also be added on the right side, okay? So on the other side, we have k times 2k plus 1 plus 4 times k plus 1 minus 1. So we have here, we can actually copy this one and evaluate this one. So 2k times k is equal to 2k squared plus k plus 4k plus 4 minus 1. And we combine like terms. So 2k squared plus the two terms that are the same are k plus 4k. So that is equal to 5k plus 3. And this equation can also be factored out. So we have the factors k plus 1 and 2k plus 1. And lastly, we have the factor k plus 1 multiplied it with 2, k plus 1 plus 1. Okay? So we already proved that pk plus 1 is also true. This is correct because we have it here. Hence, the assertion is also true for k plus 1. Therefore, by the principle of mathematical induction, 3 plus 7 plus 11 plus dot 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 plus 4k minus 1 equals k times 2k plus 1 is also true for all positive integers n. End of proof. Yay! We're done with our discussion. I hope that you learned something from this video. Thank you so much for watching this video. God bless.